Hey there, ladies and gents, Mr. D here, and in this video we are going to be talking about radian measure and how radians show up on the unit circle. So far we've already discussed the unit circle, but specifically we talked about, what does it look like with degrees, but now we're going to start throwing radian measure in there. Before we do that, let's kind of recap what we know about radians. Radians are another way to measure angles, and we know that pi radians is the same thing as saying 180 degrees. Similarly, 2 pi radians would then be 360 degrees. Now, since we have a unit of pi to represent 180 degrees, we're going to start seeing some fractional radian measures like pi over 6, pi over 4, pi over 3, 2 pi over 3 to represent smaller angles. But as long as we have this general conversion, we should be okay. So let's do a little warm-up here. Problem number 1, Chef Bab believes that a perfect slice of pizza has a central angle of 1 radian. So we've got a pizza. We're assuming it's a circular pizza. And Chef Babu says, oh, that's not a good central angle. But he says that that angle right there is 1 radian. And we want to know how many perfect slices can he get out of 1 pizza? How many perfect slices could he get out of 1 pizza? Well, as I'm going around, I know that there are 2 pi radians in 360 degrees. So that's a full 360 degrees. So I know that there's 2 pi radians, which is about 6.28 if I typed in pi to my calculator. Now, if I want to know how many perfect slices there are, well, there'd only be 6 perfect slices because that 0.28, that's just going to be like a weird little sliver. No one wants that. So according to Chef Bob, we would have 6 perfect slices. All right, next one. Which pairs of measurements, I guess should be pair of measurements, represent the same angle measures? Choose all that apply. Okay, choose all that apply. So right here we have degree measure, we have radians. We want to know which pairs are saying the same thing. My suggestion to you, because I know we're not super familiar with radians yet, is take all of the radians and convert them to degrees. The conversion factor to do that is 180 over pi. Now the way this works out, I'll use this first one for example, is if I have 7 pi over 6, and I'm multiplying that by 180 over pi, the pi's are going to cancel out, and then I can take a look at the 180 over 6, and I can say, okay, 18 divided by 6 is 3, so 180 divided by 6 would be 30. So this is really just saying 7 times 30, well, that would be 210 degrees. 210 degrees is clearly not the same as 240, so option A is out the window. Part B is going to be the same exact thing. We have 3 pi over 4. Let's convert that into degrees because we're comfortable with degrees for right now. Pi's will cancel. 180 over 4 is 45. So now this becomes 3 times 45. Well, yeah, that is 135, so that works out. Next, we have 5 pi over 6. Same thing. Let's convert from radians into degrees. So 180 over pi, pi's will cancel. And then we've got 180 over 6. Well, that reduces down to 30. We already said that from that first example. So this is 5 times 30, and that's 150 degrees. So yeah, this works out as well. So B and C would work. All right, so now let's talk about the unit circle using radians. The unit circle using radians. And fret not, people, fret not. I promise you this will not be terribly scary. This first angle measure right here, if we were thinking degrees, would be 30 degrees. Now, if I wanted to take 30 degrees and convert that into radians, I would tack a pi on it, and I'd throw it over 180 and reduce. So 30 over 180 is 1/6, so this would be pi over 6. The second angle here, this is the 45. We do the same thing. If I know that's a 45-degree angle, but I want to convert it away from degrees to radians, I'd multiply it by pi over 180. So 45 over 180, if I reduce that down, is 1/4. So this would be pi over 4 radians. Now we can keep doing that all the way around. When we do that, here's going to be the result. So 30 degrees is pi over 6, 45 is pi fourths, 60 is pi thirds, 90 is pi over 2. Now a few relationships to pick up on. All of my 30-degree reference angles, oops, let me use a highlighter here. All of my 30-degree reference angles, regardless of the quadrant, they all have a denominator of 6. So 30-degree reference angles all have a denominator of 6. 45-degree reference angles, every single one of them will have a denominator of 4. 60-degree reference angles, all of them have a denominator of 3. Well, now we have to figure out, okay, if I can memorize the 6, the 4, and the 3 and kind of knowing which one's which, what's going on with the numerators? Well, here are some patterns. In quadrant 1, all of the numerators are just 1 pi. Nice and easy. All of the numerators are just 1 pi. In quadrant 2, all of these numerators are exactly 1 less than the denominator. So if the denominator is 3, the numerator is 1 less, 2 pi. Here, denominator is 4, so numerator is 3 pi. 6 gives us 5 pi. So quadrant 2, the numerator coefficient is always 1 less than the denominator. Quadrant 3, flip that. The numerator is 1 bigger than the denominator. So 7 is 1 bigger than 6, 5 is 1 bigger than 4, 4 is 1 bigger than 3. So quadrant 1 is always 1. Quadrant 2, numerator is 1 less. Quadrant 3, numerator is 1 more. Quadrant 4 gets a little tricky. In quadrant 4, the numerator is 1 less than double the denominator. So 1 less than double the denominator. What I mean by that is double of 6 is 12, so 1 less than 12 is 11. 2 times 4 is 8, 1 less than that is 7. 2 times 3 is 6, 1 less than that is 5. So these are just little mental tricks for you to remember kind of which ones go where. As long as you know the denominator and you know the quadrant, you can figure out what angle goes where. Now the behavior of each of these is going to be the exact same thing every single time. So we're going to have the same sine and cosine values that we've come to know and love. Right? And if you need a full-blown unit circle, either Google unit circle. Hey, I goofed. Either Google unit circle, or you can, reference back to a previous notes file and go there. So we're going to steal these same values and just kind of toy around with positive versus negative values. All right, coterminal angles. Let's see, using our prior knowledge of coterminal angles in degrees, how do you think you'd find coterminal angles in radians? Well, when we were talking degrees, that's when we would add or subtract 360 degrees to an angle. Right? So if I had a 30-degree angle, I have a coterminal at 390. I have a coterminal at negative 330. And all I'm doing is just adding, subtracting 360. Well, if we wanted to do that with radians, we would add or subtract. What's the radian equivalent of 360? That would be 2 pi. We would add or subtract 2 pi. So this is saying, could I find a positive and negative coterminal angle for pi fourths? Well, I could by adding, subtracting 2 pi. Or if you're totally terrified of radians, and I do not recommend doing this, you could convert this to degrees, find your two coterminals, and convert them back to radians. But that's too much work. So I'm going to do pi over 4 plus 2 pi, pi over 4 minus 2 pi. So pi over 4 plus 2 pi, and pi over 4 minus 2 pi. Well, hopefully we remember, in order to add fractions, we need to have common denominators. Right now, the denominator underneath that 2 pi is technically a 1. So I need to do some adjusting here. I could say pi fourths plus 8 pi fourths. Right, this has the same value as 2 pi. I just kind of unsimplified it strategically so that I get the denominator I want. So I'll just multiply bottom and top by 4. I can do the same thing over here for the subtraction. So pi over 4 minus 8 pi over 4. And now we can simplify these. I've got pi plus 8 pi. There's technically a 1 on the coefficient of the pi's, even if it's not written. So my two answers here, let's see, 1 pi plus 8 pi is a 9 pi over 4. And then 1 pi minus 8 pi would be a negative 7 pi over 4. Those would be our two coterminal angles. So the conclusion here, we already kind of discussed it. Two coterminal angles for radians can be found by adding or subtracting 2 pi to your original angle. Remember that symbol is theta, and that indicates an unknown angle. All right. Let's get some coterminals. For number 1, we're going to add or subtract 2 pi. We're going to add or subtract 2 pi, but we need to be strategic how we write it. I'm not going to call it 2 pi. I'm actually going to call it 10 pi over 5 because I want my denominator to match right there. So we're going to have 3 pi plus 10. That's 13 pi over 5. Ooh, that's a nasty 5. And then we're going to have 3 pi minus 10 pi, so negative 7 pi over 5. Let's do the same thing here for negative 5 pi over 8. What I'm going to suggest is move that negative onto the numerator just for simplicity's sake. We're going to add or subtract 2 pi, but I can't just think of it as a 2 pi. I'm going to think of this as a 16 pi over 8. Basically, I just want the numerator twice as big as that denominator. So if I did negative 5 plus 16, negative 5 pi plus 16 pi, I'll be at 11 pi over 8. Then if I did negative 5 pi minus 16, I'd be at negative 21 pi over 8. So those are my two results. Next one, 12 pi over 5. So I'm going to add or subtract 2 pi to get my coterminals, but it's not going to be 2 pi. It's going to be 10 pi over 5. So if I subtract 10 pi over 5 from 12 pi, it's still going to be positive. So let's see, 12 pi over 5 minus 10 pi over 5 would be 2 pi over 5. And I could subtract 10 pi over 5 again from that to get negative 8 pi over 5. So this one we had to subtract away both times instead of adding, subtracting, because this angle kind of already did one full lap around our graph. All right, let's get into evaluating sine and cosine values using our unit circle. And again, with the unit circle, it's going to be important to keep in mind the cosine and sine values. So we have rad 3 over 2, comma 1/2, rad 2 over 2, comma rad 2 over 2, 1/2, comma rad 3 over 2, and all of these are written in the format of cosine theta, comma, sine theta. So it goes alphabetically. X value is cosine, Y value is sine. Other notes I'm going to make on here is all of my pi over 6s will behave the exact same way. All of my pi over 4s will behave the exact same way. The only difference here is going to be positives versus negatives. Same thing with the pi over 3s. All right, let's get going. First one, we have pi over 6. That is this guy right here. There's my cosine, there's my sine value. Little thinking is needed there. Pi over 3, this guy right here. Cosine is 1/2, sine is rad 3 over 2. Negative pi over 4, so that would be going backwards pi over 4. if I think of that as a positive angle, it would be 7 pi over 4. Remember, the negative angle just means we're going backwards. So this is going to be rad 2 over 2 for both, but the y value is going to be negative. And in case we need to see it, quadrant 1, both positive. Quadrant 2, negative, then positive. Quadrant 3, both negative. Quadrant 4, positive, then negative. All right, number 3. Hey-oo. So our x value there, or sorry, our y value was negative. 2 pi over 3. 2 pi over 3 is this guy here, so it's a blue one. So it's going to be 1/2 and a rad 3 over 2. But since it's in the second quadrant, the cosine has to be negative, the sine is positive. And as we go, we can kind of continue to refer to this unit circle to get these remaining ones. So let me clear out these little boxes here for us. There we go. Again, all we're doing is plagiarizing from the unit circle to get those values. If you need to pause the video here just to kind of confirm. But then we have issues like this, 13 pi over 3, and that shows up nowhere. 13 pi over 3 shows up nowhere on the unit circle. So how do I handle situations like this? Well, 13 pi over 3, that tells me we've probably gone around multiple laps around the circle already. So let's start taking away rotation. So I'm going to take away 2 pi, but when I do that, I have to write it as 6 pi over 3 so that we have common denominators. So let's see, 13 pi minus 6 pi is 7 pi over 3. Does that show up on my unit circle? 7 pi over 3, it does not. Let's do that again. So we'll subtract away another 6 pi over 3, taking away another rotation. That'll give me 1 pi over 3. Does that show up on our unit circle? Sure does, right there. So cosine's 1/2, sine is pi over 3. Or sorry, cosine is 1/2, sine is rad 3 over 2. And last but certainly not least, this one's going to be the same concept. Negative 17 pi over 6 doesn't show up on our unit circle, so we'd have to add 2 pi. But when we do that, we're going to add 12 pi over 6. Whoa, my stylus went crazy. So if I added 12 pi, that would be a negative 5 pi over 6. Do it again. So negative 5 pi plus 12 pi. I'd get 7 pi over 6. We'd find that on our unit circle. X value is the cosine, Y value is the sine. All right, that wraps it up for this video. You know the drill, folks. If you have any questions, do not hesitate to ask. And as always, good luck, have fun, be safe, roll tide.